Right. Assalamu alaikum warahmatullahi wabarakatuh. Am I audible?
Yes.
Okay. So we are meeting after a long time. I'm really sorry because this week I was a bit busy. That's why I couldn't conduct classes during school holidays.
Oh yeah, that's okay. I still have another 5 weeks of holidays, or
Five
yeah,
weeks of
4 weeks. And
holidays. 5 weeks.
yeah, because this is my big holiday break.
Okay, that's fine. That's fine. Okay. So okay. Now let me first share the screen. Uh, sure. Okay, so do you remember what we studied last time? I think we should have completed here, right?
Think so. Also, inshallah, are we planning on starting module 7 today?
I'm sorry?
Inshallah, are we going to start module 7 today?
Today.
Yeah. Or
Organic
next
chemistry?
class?
Here.
Uh, yeah, okay.
Oh, no, I'm asking you are going to start anywhere else or should I start module 7
Oh
today?
no, I'm asking, can we start a bit before? Because we're done with module 6, aren't we?
Yeah, module 6, that's what we are discussing, and I think I didn't teach you the titration completely. I think we have completed till this, what do you call this?
Oh, okay.
Henderson-Hasselbalch equation, right?
Okay.
Okay. It doesn't matter. If you wish, we can start this organic chemistry and parallelly we can complete this titration concepts also, right? And I want
Yeah,
to just
okay.
confirm if I taught you this buffer solution.
You mentioned it, you didn't fully teach it.
Okay, so buffer solution mean that is nothing but the equation that we have studied, Henderson-Hasselbalch equation, that can be applied to a buffer solution, right? So to understand this titration clearer, we have to know some basic ideas about this buffer solution. And as far as I remember, I did only this strong acid and strong base titration in a question. Isn't that so? Did we complete?
Yes.
Yes, I think, yeah. And should I go over it again?
Uh, yes, please.
Okay, nice.
I'm gonna send you my notes on titration as well quickly.
Okay, that's fine.
That
So you have the notes?
here.
Yeah, okay. So
Yeah, I'm
have you
sending you
scanned it
photos
already?
now.
Yes.
Give me a second.
Okay.
They are handwritten, so the handwriting isn't that good, but should be fine. I sent you the photos on WhatsApp.
Yes, okay.
What's after organic chemistry?
I'm sorry?
What's after organic chemistry?
After organic chemistry in your modules, I think that is the module 8, right?
Yeah.
So the topic's name is applying chemical ideas. So we should
Okay.
majorly focus on the industrial side, right? So how we can apply our chemical knowledge in the industrial processes, right? And if industrial processes are happening, what we can do, what we can encounter is the environmental issues, right? So what are the environmental
Yeah.
issues that we can encounter when we are performing industrial processes, and how we can eliminate them, right? So what are the alternative methods and how we can reduce them, and how we can get benefits from the chemicals without harming the environment. That's what we are going to discuss, I think, right? So I didn't go through your notes. Anyways, we will see, right? So first,
Okay.
so you said you will be having your vacation for another 5 weeks. So it's
Yeah.
approximately 1 month. After that, you will have to study 2 weeks. I'm sorry, 2 months for your next examination, right?
Yeah.
Okay, okay, that's fine. So so far you have, now you are in grade 12, and you have completed only first term, right?
Yes.
Okay, and you have three remaining terms, second, third, and fourth, right?
Yes,
Right.
but fourth the fourth term exam is for everything in year 12. So,
Yeah,
and
so
then I
that will
also
be
have
the final one,
another
right?
exam
So I
after
think that
that, the
will be the
actual A
final.
level exam after that as well. Yeah.
Yes, so that will be considered as the final examination, right?
Yeah, final school exam, and then I have the final one, like
Okay, okay, so I
the,
understood, right?
yeah,
So you will be having the fourth term examination. After finishing that, you will be having the final
yes,
examination. So after
yes.
studying this, after completing this fourth term, you will be having two examination. The first one is like term, and the other one is final, right?
Not after completing it. So the first one will be in the start of the term, within the first 2 weeks,
Okay, so
and then
okay,
the last
right.
one will be at
Okay,
the
so
end. Yeah.
let me sketch a plan here, right? So now you are in grade 12. Now first term you have
Do you
completed,
want me
right?
to show you? I can show you my maths plan, because for maths the teachers give us a proper plan with like the
Okay,
approximate dates
so
and
can
all.
you just send me the plan of the picture of the plan so the yeah.
Can I just share screen, because I don't actually
Okay,
have
okay,
a.
that's fine. Yeah, I will stop share. Can you just check if you can share the screen? Otherwise, I will have to allow you. Yeah.
No, I sent a request
Okay,
now.
so I will allow. Right. Okay.
Okay, let me share now. Okay, so this is my maths one.
Mm-hmm.
So we have already completed this part. So this will be start of February.
Mm-hmm.
Wait, no, sorry, that's my mistake. We've completed this one, and this will be the start of February
Okay.
through through to week 11, and then we'll have a 2 week break after this.
2 weeks. So after
After this,
completing your second term
yeah,
examination, you will have only 2 weeks, like short vacation.
yeah, we'll have a short vacation,
Mm-hmm.
and then our exam is here for the third term technically. Term
Okay.
two of term two of the year, but third term because we already did one term last year.
So in
So,
which month will it occur?
uh, approximately. Let me check. Give me a second. 125 days. So give me 1 second. So this starts on 14th of April to 24th of April,
Mm-hmm.
and then this so then this whole term ends at ends 7th of, or like ends on the 4th of July.
Mm-hmm.
So end of June, approximately. Yeah, last 2 weeks of June.
Last 2 weeks of June. Okay. Right. And then
And
what
then
is this revision?
this revision block, these are just in school we go, and the teachers don't teach us anything. We just revise everything.
Okay. So so
And then
during
this
that
is
week you will
the
not
term
have
four
you will
one.
not be having your school, right? So you will attend the school, but you will be not having any sessions.
Yeah,
Okay.
but we also might skip a few days to study at home and all, you know?
Okay. Okay. Okay.
Yeah.
After
Because we
that.
won't actually learn anything at school after about, not even here, after about here, we won't learn anything at school. Because they'll try and put this in before as well.
Right. Right.
Like the bits after before as well. So after about there, we won't learn anything at school. It's just revising everything.
Right. So you
And
okay? So what do you expect to? When do you expect to uh, happen the final
finish.
examination? I mean, when will your final examination happen? Approximately.
So final examination is midway through September. up to start of November.
Okay. So for that final examination, you will have to cover all the things that you have studied in grade 10, I mean 11 and 12, right?
You're talking about the final exam in school. That one's before because we have the final examination in school, and then we have the nationwide exam as well.
Okay.
So the
So
final
totally you
exam in
will be
school is
having
is
three
this
examination in the fourth term itself.
yeah, so that's this one, which is the approximate date is so that's it. So wait, give me 1 second. I'm trying to figure this out. So this is April, and then this is July.
Mm-hmm.
Oh, so it'll be end of July.
End of July.
End of July, start of uh August.
Fourth term.
Yeah, end of July, start of August.
End of July, start of August. That will be the beginning of your fourth
Because here,
term, right?
yeah, because
Okay.
this will start on the 18th, and
Okay.
then we'll have a week of revision,
Okay.
and then final exam starts. And then we have another final exam a bit later on,
Okay,
around the
so
end
this
of the
is so you
September
have
to
here
start of
I
November.
can see in this block trial examination. The trial
Yeah,
examination
that is
will be the
the final
beginning of
exam.
the term examination. I mean the beginning of the term.
Yes,
Okay,
this trial examination is beginning of August.
beginning of August, right? So we have enough time. We can
Yes.
complete the entire syllabus, and I think we have almost covered the syllabus for the second term also, right? Uh,
Yes.
okay, then so we have to just practice some more questions. That's sufficient.
Yes. So I think what we can do is finish the syllabus, and then you just ask me a lot of questions and I'll practice a lot.
Okay, that's fine. That's fine.
Yeah.
And if you wish, we can today itself we can start the organic chemistry. Parallelly, we can continue both, right? So that you can get
Okay.
in touch with both subjects, right?
Yeah, okay.
Now, okay. So
I
can you?
don't have I have my module 6 notes here, but
Okay.
because we have completed module 6,
Mm-hmm.
I don't think it'd be that worth it because I went through the booklets as well and it's the exact same as what we've learned. Like there isn't anything extra or anything.
Okay.
So
So you have learned whatever
it's
I
not that
taught,
worth it.
right?
Yeah.
Okay.
And
Then
I won't
it's
get
fine.
my module 7 booklet for another 2-3 weeks at least.
Okay. So what you can do is you have already completed your grade 11 also. I didn't teach you anything in grade 11 and I didn't
Yeah.
go through your modules also, right? But
Yeah.
we have practiced many past paper questions and they were very simple, right? We have done questions from grade 11 also. If you have time, you can scan you scan your notes and send me as a
Okay.
PDF so that I can just go over it to have some ideas of how to teach you, right?
Okay.
And then we don't need to worry actually. We can complete, don't worry. And your
Yeah.
consistent practice will bring you the success. Don't worry. Okay. So you
Okay.
can now stop share,
Yep.
and okay. What is that? Right, so now let me go to this. Okay, so we will study this organic chemistry later, but now we will just module 6, right? So your titration, yes. This one, this one also. Yes, that. Ouch. Though I have inserted this file in module 5, this is related to your module 6, right? Because we are studying
Okay.
equilibrium in Sri Lanka, that is taught in a particular unit. That's why. But anyways,
Oh,
whether
okay.
it's in Australia, Sri Lanka, or anywhere in the country, the chemistry is the same. Only the conditions
Yeah.
will be different, right? So the temperature conditions will be the different. Okay. So you have completed this. What do you call this? Gaseous states of matter, Avogadro law, and ideal gas equations and everything. In your grade 11, am I right?
Yeah.
And energetics we studied in this module 5. Yeah, module 5. Anyways, let me insert a new page and discuss this buffer solution. Okay, so we will cover about this buffer solution. Let me change the color. Right, so we will discuss about this buffer solution, right? So I already told you what this buffer solution is. Do you remember?
Not exactly.
Yes. So what is buffer solution? It will be pH resistant to a small amount of acid or base, right? So let's say we have a solution, right? So as the name suggests, we should have a solution. In the solution, if you add small amount of H plus or small amount of OH minus, the pH will not change. pH will not change. This is the idea behind this buffer solution. Okay, right. So if the pH doesn't want to change, what should we have into the solution? So I already told you that for buffer solution you can apply this Henderson Hasselbalch equation, right? So I already told you, I might have given you a homework to write down the equation, especially the Henderson-Hasselbalch equation for a weak base, and we studied for weak acid, right? Okay, now tell me what should we have into this solution if pH doesn't want to change. For what kind of
Sorry?
solution do we use this Henderson-Hasselbalch equation?
For buffer solutions.
Yeah, no, for buffer solution, right? So we
Yeah.
already discussed it should have the weak acid and its weak acid salt or conjugate acid, right? So it should
Yeah.
contain either the first one is weak acid or weak acid salt, right? Weak acid salt or weak base or and its weak base salt, right? Weak base salt. For example, let's say we have acetic acid, right? CH3COOH, and into the solution itself we have its salt. So what's the salt of this acetic acid? For example, let's say we titrate it with sodium hydroxide. So we will have the salt as CH3COO minus Na plus. So we are not going to bother about this Na plus. Why? Because even though if you have OH minus, it will not combine with Na plus to form NaOH again. Why? Because NaOH is a strong base. So it will not go backwards, right? So we are not going to write down this Na plus. That is not necessary, right? So let's say we have a solution of this CH3COOH and CH3COO minus. Okay. Now let's say I putting some amount of H plus. What will happen?
If you put H plus, it will form hydronium, right?
Yeah. Now if you put H plus, what will happen? it will not produce hydronium because we okay now we are putting H plus mean we are adding acid, so HCl. So we are adding H plus ions, right? So oh no, H plus, we are putting H plus mean. Now I am telling this, now you shouldn't think it as an abstract thing, right? So practically we are putting some amount of H plus, means we are putting some HCl, some drops of HCl, right? So we are not interested in the Cl minus. Why? Now even though we have Cl minus, the Cl minus will not combine with H plus again to form HCl, right? Why? Because HCl can dissociate as H plus and Cl minus, but this reaction cannot happen backwards. So even though actually literally what I am doing is we are putting what do you this? Let me write over here. Now literally we are putting HCl, right? So now let's say we have CH3COOH and we have titrated with NaOH, right? So when I am teaching titration, we can study later, right? So what we will do is we will take CH3COOH in the Erlenmeyer flask, and from the burette we will be putting what do you call? We will be titrating it with sodium hydroxide. So the volume of the sodium hydroxide is going to change. So during a particular time, we will now the buffer solution will be formed. Buffer solution will be formed mean we will be having the undissociated acetic acid and its salt. So in that case, what will happen is the pH will have a resistance. pH will not drastically increase. The pH will be remaining the same, right? So when you add, right, so in that situation, if you extract some amount of that solution, right, so let's say we are titrating, right, so here we have what do you call this, acetic acid, and you are titrating it against this NaOH, right? So during this time into this solution we have CH3COOH and CH3COO minus, right? So we just stop the titration, and from the Erlenmeyer flask we take some amount of sample. We take a small amount of sample, and now we have collected it here. Now we haven't titrated it with HCl. Why? Because CH3COOH itself is an acid, so we cannot titrate it with again HCl. Why? Because HCl is again a acid, right? So titration should happen between acid and bases. Acid and bases we already discussed, right? So this is just an experiment. We just want to check if you add some amount of HCl to this solution or to this sample, will the pH change? Will the pH change? Now definitely if you are increasing H plus, if you are putting HCl, what are you doing? Literally you are adding H plus, so the H plus concentration is increasing. The H plus concentration is increasing. You are literally increasing the H plus concentration. So what should happen to the pH of the solution?
It will increase.
If you are increasing the H plus, what should happen to the pH?
It'll become more acidic, right?
I'm sorry?
It will become more acidic.
Oh, more acidic. So what will happen to the pH?
It will decrease, not
It
increase.
will decrease. It will decrease, right? Okay. Now tell me, if you put H plus HCl, you are putting HCl, right? HCl. So we don't want to bother about the Cl minus. So if you are putting H plus into the solution, we have CH3COO minus. So what will happen? H plus and CH3COO minus will combine together to form CH3COOH again, right? So has the concentration of this H plus increased here? What do you feel?
Can you repeat the question?
Has the concentration of H plus, even though we additionally put some H plus, now it has become CH3COOH. So H plus concentration is utilized, right?
Okay.
Okay.
Oh yeah.
Yeah, right.
Because
so do you understand? So now
okay.
even though you are adding H plus in the solution, it does not exist as H plus. It will become CH3COOH, right? So now
Yeah.
what do you think? Will the pH change?
No.
No. Why? Even though you added pH H plus, the pH has not changed. Why? Because of this present of this salt, right? So let's say if this salt is not present, what will happen to the H plus? What will happen to the pH? It will definitely increase. Why? Because we have nothing to combine with this H plus to what do you call this, to eliminate it, right? To eliminate it. But here the H plus has been eliminated by the CH3COO minus salt to form CH3COOH. So the pH will not change. pH will not change. Okay, do you understand? Right. Now let's see what will happen if you add OH minus to the same solution, right? So we have CH3COO minus and CH3COOH. So what will happen if you add OH minus?
Can you repeat it?
So in the CH3COO, okay, in the solution it will have a particular pH. Now we have to check if this pH will change, right? So
Yeah.
based on the H plus concentration present in this solution, we have a pH. So if there is any change in the H plus due to our amendment, the pH will change. But here if you are adding OH minus, this CH3COOH will be present as CH3COO minus and H plus, right?
Yeah.
Okay. Now what will happen if you add OH minus? This OH minus will react with H plus and form H2O. So even though you added OH minus additionally, it has been eliminated by the H plus to produce, or it has been neutralized, right? So
Yeah.
even though you added OH minus, now the solution itself is converting it to water. So that is a neutral substance. So the pH will not here also change. pH will not change, right? So why? Okay, now I mentioned that we have to put small amount of H plus, right? So I mentioned if you put small amount of H plus, but if you pour OH minus in large quantity, definitely the pH will change. Why? Because we know that for example, if you take H2O, let's say H2O can dissociate as H plus and OH minus, right? So if we have 1000 mole of H2O, we may have 5 mole of H plus and 5 mole of OH minus. So the forward reaction may happen even if the water is present in large quantity. But if the backward reaction, here we are literally writing the backward direction reaction, right? So if the backward reaction should occur, we should have small amount of OH minus and small amount of H plus. Then only the backward reaction can occur, right? If you have 5 mole and 5 mole of OH minus, only it will possible. It will be possible. Do you understand that? But if you pour more amount of H plus, definitely the reaction, the pH will be changed, right? Have you understood that? Okay, now can you just give me an idea about what this buffer solution is according to what I have explained now?
So a buffer solution occurs after the dissociation of something like acetic acid, and then the pH of the buffer solution does not change. Even
When does the pH not change?
Sorry?
Okay, now you mentioned that the pH of a buffer solution does not change. In which situation?
When it's a when it's a strong acid.
You don't want to mention strong acid. Simply you can tell, now I told you, let's say we have a solution. If you add small amount of H plus or small amount of OH minus, the pH will not change. Those kind of solutions are called buffer solution. And what can act as this buffer solution is weak acid and weak acid salt pair. and weak base salt pair, right? Now
Okay.
I will give you some more examples, right? So now here we will just check, right? Okay, now let's say we have NH, so NH4OH is a weak base, right? And its conjugate acid is NH4 plus, right? Or we can say weak base salt, right? So now let's say we have NH4OH and NH4 plus. Now let me change the color. Right, now I am adding H plus. What will happen? Now NH4OH can be NH4 plus and OH minus, right? So if you add H plus, it will combine with this OH minus and produce water. So even though you are adding H plus, the H plus concentration is not literally changing, so the pH will not change. Do you understand?
Yeah.
Okay, now let's say I am adding OH minus. What will happen? Now if this OH minus is added, it will again react or combine with NH4 plus to produce NH4OH, right? So if you have NH4OH, now it is a neutral one, right? Not neither OH minus or nor H plus. So the pH will not again change. But this H plus and OH minus should be small amount, in small quantity, right? Small quantity. So this is acting as a buffer solution. Right? Okay. Now let's say we have sodium chloride. Okay, sodium chloride, and we have HCl. Can this act as a buffer solution?
NaCl and then HCl. So it can't.
It is obvious, right? Because why? Again, even though you put H plus and OH minus, H plus cannot react with or combine with Cl minus to produce HCl. So definitely the added H plus concentration will influence the pH, right? So now let's say we have NaCl and HCl. Now NaCl means it will be present as Na plus and Cl minus, and HCl will be present as H plus and Cl minus. Now let's say you are putting OH minus. This OH minus can either combine with Na plus or H plus, right? So if you put if you combine with Na, okay, now let's say you are putting OH minus. So always the system wants to be at equilibrium, right? Then only it can be stable, right? So nobody will expect a sudden change. Right? So if you put OH minus, what will happen if the pH increases or decreases? The stability of the solution will reduce, right? So let's say okay, for example, if I say an example, a man is there. Okay, now the growth of a human should be gradual, right? So if it is a gradual increase, he will not be stable. Let's say a lot of wealth come to you suddenly, so it can now you will not be stable, right? Mentally you will not be stable. So similar concept can be applied to a chemical system also. If there is a sudden change in the pH, the solution will be unstable, right? So now let's say OH minus will come. Okay, Na plus is there, because always negatives prefer positives, right? So Na plus, but they cannot form NaOH again, right? Why? Because NaOH is a strong base, so NaOH cannot be formed. Okay, now OH minus is coming. Okay, H plus is there again.
Sorry? Hello?
Yeah, I'm sorry. Yeah, okay.
Yeah.
Here OH minus. NaCl, HCl. Yeah, okay, let me, okay, right. So, right, here, okay, OH minus is coming, H plus is there, so H2O will come, right? So here, if you add OH minus, here the pH will not change. pH
Yeah.
will,
You know.
will change. Why? Give me a sec. Yeah, because
Well,
will not change. Will not change. I'm sorry. Wait. Because okay, now Na plus is there because only for H plus it will not change, right? So let me construct the sentence. OH minus will come, but here the pH will not change, right? So as usual, the pH will not change. Why? Because the added OH minus will be converted to H2O by this H plus, right? But now let's consider if you add OH minus, I'm sorry, H plus, right? H plus, right? If you add H plus, what will happen? Now H plus will come and combine with this Cl minus, but we have only Cl minus as the anion in the solution, right? So if H plus comes, there is nothing, there is no potential or viable anion to convert it into a neutral substance which cannot produce any H plus or OH minus to change the pH, right? So do you understand that? For OH minus, the pH will not change. Why? Because H plus is there to convert it into water. So it will be eliminated. The added OH minus will be eliminated. But if you add H plus, what will happen? Here we have only Cl minus. So H plus cannot combine with Cl minus to produce HCl, right? So if you add H plus, definitely pH will change. pH will change. Why? Because we have nothing to convert this H plus to
water.
HCl or any other neutral substances, right?
Yeah.
Right. So here pH will change. So when you add H plus or OH minus, if the pH changes, it cannot act as a buffer solution. So this solution is not a buffer solution. Do you understand that? Since because the H plus, if you add H plus, definitely the pH will change. Only for one factor. But for buffer solution, both conditions should be satisfied. If you add OH minus and H plus, in both situations, the pH shouldn't change. Okay?
Okay.
Right. Now, for example, let's say, okay, now we have taken strong acid and its salt. Let's say we have NH4Cl and HCl. NH4Cl. Any solution can be checked if it is buffer solution or not, right? NH4Cl and HCl. So how can you comment on this?
So NH4 and then Cl. So this associated to NH4 plus and then Cl minus and H plus Cl minus. If you add OH minus, the pH won't change. If you add H plus, the pH will change.
Yeah, why? Because we have nothing to convert it into HCl, right? Because HCl cannot be produced by combining H plus and Cl minus. So this is also not a buffer solution, right? This is also not buffer solution. So this is how you have to comment on this. Okay. So for this kind of buffer solutions, we can apply Henderson-Hasselbalch equation, right? So now we will go for this titration. Right. So you can see here, here we have conjugate base and acid. So this can be a buffer solution, right? So if you have conjugate base as NH3 and NH4 plus, right? So how can you comment on this? So if you add H plus and OH minus, the pH will be resistant. So you can
Yeah.
apply this chemical formula, right? So you have to find out the concentration of the base and acid, and then you can find out the pH, right? So why now you see here for a pH, for the pH, this Ka value is a constant, and the conjugate bases this numerator is a constant. This acid also, the concentration of acid also constant. Now you see the entire expression in the equation is a constant, right? Constant. So the pH also should be constant. It cannot change even though if you add H plus and OH minus. Do you understand that? But if the
Yeah.
general equation pH is equal to minus log H plus concentration, this H plus concentration is not a constant. Do you understand? Because it can change. The H plus concentration cannot change. But for conjugate base and acid concentration that we are using, these are constant. But can the H plus concentration be constant? Because we are using it in titration, right? So if you are adding
Yeah.
H plus or if you are adding OH minus in the titration, definitely this H plus can change. So that's why we can get different values for this pH. But in this situation, if you apply this formula in a buffer solution, the pH will be constant, right? Okay. Now, okay. So volumetric titration, I already told you this volumetric titration is a quantitative method for finding out the concentration of an unknown substance, right? But theoretically, what we will study is we will take the known concentration for both acid and bases to sketch a graph, right? So we will call it as titration curve, right? So in the titration curve, as usual, we will be having two axes. In the x-axis, we will put the volume of the substance that we are putting in the burette. Why? Because by definition, what in x means it is what variable? Independent variable or dependent variable?
Independent.
Independent variable. So independent variable is what we are changing, right? So it will be the volume of the substance in the burette, right? So you know the burette. Have you seen burette in the laboratory?
Yeah.
Okay. Then what we will measure here is y, right? So what is y here? This is independent variable. So what we will measure during an experiment will be the dependent variable, right? So here the pH of the solution, will be the y. Now we are going to sketch graphs. Okay, we are going to sketch graphs. Before that, volumetric titration mean it's a procedure. Now you can just see them, read them, right? It's a procedure for determining the concentration. So we will use this in the laboratory settings to determine the concentration of an unknown thing. But for that, we should have a standard solution, right? So you know the standard solution. This is a important terminology, standard solution. So you might be sometimes asked to define this term standard solution. So do you have any idea? Have you already completed this titration in school?
Not in school, but my other chemistry class we did.
Okay, so what is
And
standard
they-
solution? What is standard solution?
So I have a primary standard is an accurately known chemical formula where we know the number of moles, and it is stable with no mass changes
Yes.
of react when exposed to air, and it's readily soluble in distilled water, and should have a relatively high molecular mass to minimize weighing errors.
Okay, that's fine. So simply you can tell in titration, in the context of titration, it is just a solution whose concentration is known, right? So that is a simple definition. But some substances can act as standard solution. So those are the properties you told, right, of the standard solution, right? Like KMnO4 and other stuff. Okay. So called okay. Now you see another. So okay. Standard solution here you can see. standard solution using another solution non-concentration, right? So in the context of titration, you can simply tell that the standard solution is a solution whose concentration is known, right? Okay, now we have 2 points, equivalence point and end point, right? So here equivalence point mean in equivalence point the reaction will happen according to stoichiometry, right? Do you
Yeah.
understand? So now we are going to deal with the chemical equation. So equivalence point is the point where the solution becomes neutral according to stoichiometric ratio, right? And end point mean now you see before the equivalence point we will stop adding the titrant. That point is called end point, right? So you can just read this. Okay, now for titration to be accurate we must add stoichiometrically equivalent amount of the titrant, right? So what is titrant and what is analyte? So what is titrant and what is analyte? So let's say we have this burette and here we have taken a solution, and we will typically take flask, and the name of this flask is Erlenmeyer flask. Now here we will take a solution. So how do we call this solution that you take in the burette, and what is that we take in the Erlenmeyer flask? What are the keywords that you use here? Do you have any idea? Have you heard about this analyte and titrant?
Yes.
What is
but I don't
analyte?
remember which one's which.
What is analyte and what is titrant?
Oh, so the one in the burette is the titrate.
Mm-hmm.
So the one in the burette is the titrate. The one in the volumetric flask is the analyte, I think.
Yes, analyte, right? So typically we will now, okay, now here the concentration, whose concentration should we need to find out?
We are trying to find the concentration of the in the burette, right?
No.
So the titrate.
No. Here we will have to find out the concentration of this analyte, right? But we will know the volume, right? So we should have already measured the volume of this analyte. So we know the volume, right? So the basic equation that we are going to use here is CV is equal to, I mean C1 V1 is equal to C2 V2, right? So here C is unknown, but we have already known the volume, and the concentration of the titrant, right? This should be known, and the volume we have to change, right? Even though we are changing, the volume is known, right? So in different situations, we will be having different volumes, right? So this titrant will act as the standard solution, and now we can just plug the values into this equation and find out the concentration. This is very simple. Okay, so there are a lot of things. Titration error, did you study about this titration error? So we have to take at least three volume test, and we have to take the average to reduce the titration error, right? So we have to repeat the experiment 3 times at least, and take the average volume, and if you have any odd values you have to skip, or you have to eliminate that and take the average, right? But if you can go for 5 times, that is more better, but depending on the availability of the chemicals, you have to decide whether to go for 3 times or 5 times. Did you do any experiments in the laboratory?
No, not yet.
Okay. Right. So did you study about this titration error also?
No.
Okay, that's fine. Okay. Now you can see here, this is burette and this is titration flask. Okay. Now here we will have the volume of the titrant, right? So in the x-axis we will have the volume of the titrant, and here we will have pH. And now we have many titration, right? So one of the titration is acid-base titration. Here we are going to focus on acid-base titration. So acid-base titration, we have 4 types. The first one is strong acid and strong base, and weak acid and strong base, strong acid and weak base, and finally weak acid and weak base. right? Typically the shape of the curve will be like this, right? So here you can see a steep line, right? So steep line, and there will be a pH range that will be called equivalence point, right? So this here we will have equivalence point, and from the equivalence point we will have a distance. Now we will call pH range, right? So during the pH
Okay.
range, what will happen after equivalence point? Okay, now you see this is equivalent point. Before this equivalent point, if this is acid, after the equivalent points it will be base, right? So there will be a steep change in the pH. So the midpoint of that range will be called the equivalence point. That is the simple definition,
Okay.
right? Okay. Now titration curves, that's what we have to study. Titration curve provide us with a visual picture of how properties such as pH changes as we add the titrant, right? So whenever we, okay, now you see, now what we are actually plotting in the graph, when we add the titrant, how the pH will vary. That's what we are drawing, right? Okay. Now,
Yeah.
okay, so here strong acid, strong base titration. Now I'm going to tell that we are not going to take a standard solution and an unknown solution. The concentration of both acid and base will be known here because we have to finally sketch the graph, right? So the depending on the purpose, our objective is changing, right? So here consider the titration of 25 milliliter of 0.1 mole HCl, 0.1 mole NaOH, right? So here we have taken a fixed volume of this acid, right? So fixed volume of this acid. So where should we place this acid? That's what we have to experimentally think, right? So if we want to design an experiment, we have to think which one we have to put in which container, into the butyrate or into the flask, right? So here we have been given a fixed amount of volume. So we should place the acid into the Erlenmeyer flask, right? So here we will put HCl and we have to titrate it against this NaOH, right? So this is going to be our NaOH. And here 0.1 m, here also 0.1 m, and here we have 25 milliliter. So we can first calculate the initial amount of HCl, right? So all the calculations are given here. Now I will explain step by step, right? So the first thing we have to know is initial amount of HCl is going to be what? 0.1 into 225 into 10 power minus 3, that is going to be 2.5 into 10 power minus 3 mole. Do you understand? C into V, concentration C into V, and in order to convert this milliliter to decimeter cube, I am multiplying this by 10 power minus 3, right? So now we have to find out the equivalence point. We have to find out the equivalence point. So we have already studied equivalence point will occur when the HCl is completely consumed by NaOH, right? So it will occur stoichiometrically, right? So at equivalence point, what will happen? We will have HCl plus NaOH will give you NaCl and H2O. Now we have 2.5 into 10 power minus 3 mole, right? So at equivalence point, what amount of NaOH should we add to the analyte, right? So at equivalence point, what is the volume of this titrant that we should insert to the analyte? How can you calculate?
Show amount of HCl is 2.5 times 10 minus 3 moles of HCl plus it. You can use the stoichiometric ratios.
Yeah. So if HCl is 2.5, we will require 2.5 into 10 power minus 3 mole of NaOH. So we have already known the concentration of this NaOH, that is also 0.1. So definitely at equivalence point we will require the base volume as 25 milliliter, right? So this is going to be our equivalence point. So when in the graph, right? So at equivalence point we have to calculate the pH, right? So what will the pH at equivalence point?
Sorry.
What is the pH at equivalence point?
7.
7. Why? Because we have only water, right? So the concentration of the H plus in water at 25 degrees Celsius is 10 into 1 into 10 power minus 14. So it's going to be 7. So at 25 milliliter, right? So this is going to be our volume of NaOH, the axis name. The name of this axis would be volume of, okay, let me just magnify this. Volume of NaOH, right? And this is going to be our pH, right? pH. And now at 25 degrees Celsius, the pH would be 7, right? pH would be 7. Yeah. Now, if you take, okay, now let's say before 25 milliliter, what is the nature of the solution? It is acid. It is acid. And after 25 milliliter, it will be base. Why? Because the OH minus will be in excess. So here, if you add 20, now let's say 24.99 and 25.01 or 25.1. So in that case, what is the pH? That's what we have to find out, right? That's what we have to find out. And finally, we have to plot this graph. I think I have already explained this, so I will quickly run over it. Now here we have calculated all the values, right? So initial amount of pH is 2.5 into 10 power minus 3 mole, and the amount of NaOH added. Now, okay, now we have calculated this for 25 milliliter. But what will be the situation if you add only 10 milliliter of NaOH, right? So you are adding only 10 milliliter of NaOH, right? So let's consider we are adding only 10 milliliter of NaOH. So we have to first find out the amount of NaOH. Amount means here in chemistry, amount means that should be expressed in moles, right? So 0.1 into 10 power minus 3, right? So here you can see this, that would be 1 into 10 power minus 3, right? So you know that might be a bit different, right? So in 1 liter we have 0.1 mole, so that is 0.1. okay, now this is nothing but, don't confuse, this is going to, I want to write it again and
Sorry, I'm in Melbourne right now, so I was hotspotting and then my dad left, so my Wi-Fi ran out, but now it should work.
I'm sorry, yeah, what did you say?
I'm in Melbourne right now, so I don't have a stable Wi-Fi connection, but it should work now.
Okay, that's okay. So
Yeah, so if I Sometimes I might
I
ask
just now
you.
look at the picture that you sent, right? So you haven't
Yeah.
studied this titration that much deeper. Anyways, we will study this how we can plot this
Yeah.
graph, right? After that, I will explain the picture that you sent me, right?
Yeah.
Now we will go from the basic till the advanced, right? So then you can get an idea, right? I just now
Yeah.
okay, so because the example and the concentration that every teacher takes may be different, right? So I'm just teaching
Yeah.
you based on this. After that we will so you have understood everything that you studied in the class, right? So I don't want to explain that again.
Uh, yeah.
Should I
Mostly.
explain the pictures again?
Sorry.
Should I explain the pictures that you sent again?
Uh. mm, No, I think it should be fine.
Okay, it's fine,
I'm
right?
just
So
going
we will
over it.
just
Yeah.
study
Yeah, it
based
should be
on
fine.
this one. So here, if you now what we are doing, so you should be
Oh
very
wait.
careful.
Yeah.
What you are
Question.
doing should be in your mind. You have just added 10 milliliter of NaOH. So what will happen if now what is the limiting reagent here? If you have added 10 milliliter of NaOH, what is the limiting reagent?
You have 10 milliliters of NaOH. That means you have so the what's it called NaOH is the limiting.
NaOH is the limiting reagent, right? So we have to
Yeah.
find out the amount of HCl remaining, and that will contribute to the pH, right? That will contribute to the pH. So amount of HCl reactant. I don't know if you can see my pointer.
No, I can't.
Okay. So now you can see my cursor, right? So amount of HCl reacted, right? So can you see my point? I mean cursor.
I can see where you've pressed to type, but I can't see anything else.
Okay, so because of the network stability, it might take some time, right? So you cannot instantly see that, right? Okay, so I will just annotate and explain that. Right, so amount of HCl reacted is going to be this. So we have to now find out the amount of HCl remaining, because that will contribute to the pH, right? So we had 2.5 into 10 power minus 3, and this amount will be reduced, right? So we will have only 1.5 into 10 power minus 3 mole of HCl, right? And now we have to find out the concentration of HCl. Why? Because we need the H plus concentration, right? H plus concentration. But why do we need to find out the new concentration is if you have added 10 milliliter of NaOH, the volume of the solution has increased, right? So that has become 35 now. That has become 35 now. So 1.5 into 10 power minus 3 mole of HCl we have, but it is in 35 milliliter. So what is the concentration of HCl now?
It is also 1.5 times 10 minus 3.
1.5 into that is so concentration of this one, right?
Concentration
C is
is
equal to mole
0.043.
divided by volume. Mole is 1.5 into 10 power minus 3 divided by what's the volume? 35 is the 35 milliliter, and 35 into 10 power minus 3. So 10 power minus 3. So this is how we have to write down according to our convenience, but they have written differently, right? So this is similar to this. You can understand. This is similar to this, right? So this is the mole of the HCl, and this is the volume of the entire solution including the NaOH, right? In NaOH also we have water, so the volume has changed, and if you simplify this it will become like this. So the concentration of HCl is 0.043 mole decimeter minus 3, and if the concentration of HCl is 0.043 and that is the concentration of H plus, now we can find out pH using this formula, and that would be 1.34, right? So now we have already plotted a graph. We have already plotted a graph here, right? So when you add a 25 milliliter, the pH is 7, but when you add 10 milliliter, the pH is what? 1.37. Am I right? That's that. Yeah, 1.37. Right, 1.37. Now we will see what will happen when the when you add it. Now let's say at equivalence point, what will happen? The color change will occur. So from colorless, the solution will become pink color, right? So before that, so we have to drop by drop, we have to add the NaOH before the equivalence point, right? So we have approximately found the equivalence point, and till 24 milliliter we can pour the NaOH, but after 24 milliliter NaOH has been added, you have to be very carefully add, because the equivalent point should be accurately found, right? And at that point, what will happen? The color change will suddenly occur. Why? Because the solution becomes base after adding at least one drop of NaOH after the equivalence point, right? Do you understand that?
Yeah.
Okay. Now here you can see at the equivalence point, yeah, at the equivalence point, that is 7, right? So that's what I already explained. Now after adding 35 milliliter, so again another scenario, after adding 35 milliliter, what will be the nature of the solution? That will be basic. So the pH should be above 7. The pH should be above 7, and you can apply the same procedure. Why? Okay, now tell me, in this situation, what is the limiting reagent?
The limiting reagent is the HCl.
HCl. So what will be remaining? NaOH will be remaining. So we have to again find the initial amount of HCl, that is, as we already discussed, that is 2.5, and amount of NaOH added is 3.5. So 3.5 minus 2.5, 1 into 10 power minus 3 is the remaining NaOH, right? So if you added 35 milliliter of NaOH to the acid solution, now to the acid solution of 25 milliliter, 1.10 minus 3 mole will be remaining in as NaOH. So again we have to find out the concentration, right? Now tell me, you already had 25 milliliter of acid, and you have added 35 milliliter of base. So definitely the concentration, the volume will be changed. Now what's the new volume? That is 60, right? 35 plus 25. So these mistakes you might commit in the exam. Sometimes you might forget to add this 35 to the NaOH. So you will just think, okay, 25 was the initial concentration, or 35 milliliter you are adding. So you may tend to divide it by 35. In that case, it will be a big wrong, right? It will be very big mistake. So it will affect your answer. So you should be very careful. So the amount of NaOH should be divided by the entire volume. What's the entire volume? That is 60 milliliter. That is 60 milliliter, and it is nothing, right? So 1.0 into 10 power minus 3. Now C is equal to N over V. That is equal to 1 divided by 10 power minus 3 divided by 60 into 10 power minus 3. So if you simplify this, it should be 0.17. Now if you know the OH minus concentration, you can find out the POH, that is 1.77, and subtract it from 14 and 12.23. Now tell me, if you added 10 milliliter, the pH is 1.37, and if you added 35, it has become 12.23, and in between we have 7, right? In between we have 7.
Yeah.
So again we can plot the graph. Where is that? Okay. Now if you added 35, it will be somewhere here, 12.3, right? Now we have to check what will happen if you added before. Now the neighborhood of 25 milliliter, you know, the neighborhood, very minute change, delta. Have you studied about this neighborhood in mathematics? In mathematics, do you study this?
Sorry?
In mathematics, I don't know what chapters you have. Did you study about these neighborhood functions? Do you have real analysis or anything? No. Okay. Right. Neighborhood means around, right? So a minute difference about a point is called neighborhood, right? That's nothing, right? So now we are going to consider the neighborhood of the equivalence point, right? So the neighborhood of the equivalence point, that is 24.9 milliliter. So addition of 24.9 milliliter of NaOH, right? So after adding 24.9 milliliter, still the solution is acid or base? still the solution is acidic. So the pH will be below 7. The pH will be below 7. Do you understand?
Below 7.
Okay. So now again the same procedure, but the difference in the values, right? So this is nothing. You should be very careful while dealing with numbers. That's not, other than that, nothing. Okay. So initial amount 2.5 10 power minus 3, and the amount of added NaOH is 2.49 into 10 power minus 3. How do you calculate this? Because C into V, concentration is 0.1 and you have added 24.9 into 10 power minus 3. So 2.49 into 10 power minus 3. So they have written it in a different way, right? Okay, so you can see here 2.49 into 10 power minus 3. So the amount. Now what is the limiting reagent? Again here the limiting reagent would be
Limiting reagent is the H. They're both the same. So
no. What is the limiting reagent here?
NaOH.
NaOH, right? So we have to find out the remaining one. So 2.5, that's what we already had, and this amount of HCl has reacted with NaOH. So this amount will be remaining. But now what is the what is the total volume? So already 25 plus 24.9, so it is going to be 49.9, right? So you have to divide it by 49.9. So now this is how we have to find out the concentration of HCl. So you can simply write HCl concentration is equal to 1 into 10 power minus 5 divided by 49.9 into 10 power minus 3. So if you simplify this, it should give you the answer this one. You understand? If you simplify this, you should get the answer as this, right? Now this is the H plus concentration, so you can find the pH. So when you had 10 milliliter, you had 1.37. Now it has become 37. So it is not a big difference. It is not a big difference, right? So you can again plot this here. Here 1.37. Now it has become, what's the value? I forgot. 3 point. Can you remember the value? 3 point. What's that?
Sorry, 3.7.
Right. 3.7. Okay. So now 1.37. Here 3.7, right? So you can see this type of change. And now we will see what will happen if you added 25.1, right? So if you added 25.1, now the solution is basic. The solution is basic. So you can apply the same idea here, right? So the calculation is mentioned here. You can do it yourself also. Now addition of 25.1 milliliter of NaOH, right? So 25, and this is the added NaOH. So the remaining will be NaOH. Why? Because the limiting agent is HCl here. So you can again calculate, this is the remaining, the concentration of the OH minus, and from that you can calculate the pH. But you have to be careful. If you know OH minus, you cannot directly write as pH, right? So you have to find out the pOH and you have to subtract it from 14 at 25 degrees Celsius. So these things should be, now in the exam, you have to be very careful about these things, right? So if you have found out the OH minus, you cannot directly put that into the pH equation. This is what students do, right? So we are familiar with putting the equation into pH. So after finding this OH minus, what they will do is, okay, pH is equal to minus log H plus concentration. They will instantly forget. In the examination, we are in stressed, right? So what will happen? Minus log, we will put this value here and we will get a wrong answer. So you should be very careful. And if the examiner put the value, now the examiner also might think, right? Okay, so the student may commit this type of mistake and they will get the value, making the same mistake that the student is expected to make, right? So they will put the answer that also. You will just, okay, this is the answer. You will put this. So you may be confident, but now this is what actually happened, right? So you should be very careful about these things. I'm just telling you this. Okay. Right. So now pOH is equal to 10.3. Right. 10.3 means it should be a huge difference. Do you understand that? Huge difference. Here there is a huge difference. Now it is 10 point something, right? So here this is going to be a steep increase, right? So this is going to be a steep increase, right? So steep increase. So in acid base titration, in 3 types of titration we will be having steep increase in the pH because of the equivalence point. But in weak acid and weak base there will be no steep increase because of the hydrolysis of both acid and bases. We will study that later. Now we have completed this one, acid base titration of the first type of the acid base titration, right? So now okay, you can clearly see the graph, right? Okay, now volume of the titration, when it was 10 it was 1 point something, right? And at 25 it was 7, and before this it was 3 point something, and 25.1 if you take, it was around 10 point something, right? So here you can see this is the steep increase, sudden increase in the pH, and in this region you can see this will be the equivalence point, right? So the solution suddenly becomes basic from the acidic medium, okay? And here this is the contribution of the what do you call this, indicators, right? So indicators may exhibit different colors. We will study about this. Did you study about these indicators also? Phenolphthalein, bromothymol.
Yeah.
Okay, so we will study about this now. The contribution of this, now we have a later chapter, we will study about that later. Now we will go for weak acid and strong base titration, the second type, right? So the second type. So before we begin the second type, do you have any question in the first type?
No.
Okay, right. So the example reaction that we took for strong acid and strong base titration was NaCl and NaOH and HCl. Now we have to take acetic acid, the typical acid, and strong base NaOH. So this is going to be the equation. So now you can see we are not interested in this Na plus. So simply we can write OH minus, right? So this is nothing. Now the acetate ion, here the problem is the hydrolysis of acetate ion, right? Give me a second. Okay, so here the problem is, now in the previous case we didn't have the hydrolysis of this acetate ion because we took strong acid and strong base, but strong base the weak base and weak acid may encounter the hydrolysis. Hydrolysis means if you add H2O, what will happen? It may produce the acid or base, right? So that is the hydrolysis.
Yeah.
Now here we have to use this KSP, the Ka concept and the ice table also to find out the pH value, right? So we will see, right? Now we are going to apply whatever we have studied in our previous sessions, right? Okay. Now consider the titration. This is what we are going to consider. Consider the titration of 25 milliliter of 0.1 mole decimeter minus 3 acetic acid with 0.1 mole decimeter minus 3 NaOH. And if you are using this CH3COOH, you should know the Ka value, that is 1.8 into 10 power minus 5. So in the examination you will be given the data chart. So whenever you see this acetic acid, you should either remember this value, otherwise you have to get the value from the data sheet. because we are going to use the expression Ka is equal to that expression we are going to use here to find out the H plus concentration.
Hello?
Yes, yeah.
Sorry, my Wi-Fi is a bit not stable.
Yeah, it's okay, it's okay. நான் மீட்டிங்கில் பேசுகிறேன் இன்ஷால்லா. எனக்கு வந்து நீங்கள் என்ன செய்யணும்னா இந்த குரூப்பில் மெசேஜ் ஒன்று போடுங்க, அவங்களோட அந்த ஐடியாஸோட வர சொல்லணும். என்ன சொன்னால் நேற்று வந்துட்டு தந்த அந்த அட்வைஸஸில் இருந்தால் ஒரு ஐடியா வரணும். இன்றைக்கு வந்துக்கிட்டு நானும் ஜாயின் ஆகுவேன், அடுத்த நீங்கள் நான் டேக் பண்ணல. அதில் நான் விஷயத்தை சொல்கிறேன். இந்த ரெஜிஸ்ட்ரேஷனை நீங்கள் பார்க்குறது என்னென்ன அதை பற்றி நான் பேசுகிறேன். நீங்கள் 1 o'clock வந்து okay, right. So now this is what we have taken, right? Now, right. So we are going to simply use this formula C1, or we can say CAVA is equal to CBVB. Here the subscript A represent acid and this subscript B represent base. Okay, that's what we are going to use here, right? So now the volume of NaOH, now what we are taking is 25 milliliter of 0.1 mole decimeter minus 3. So the analyte would be the acetate ion, right? And the titrant would be the NaOH. NaOH, and here this is going to be our CH3COOH. Okay.
Yeah.
Right. So now we have taken CH3COOH. First the 25 milliliter, and this is going to be 0.1 m. And NaOH. So we cannot define a volume for this analyte. Why? Sorry, this titrant, because we are going to change it. But even though we are changing it, we know the volume. Why? Because in the burette it is calibrated, we can get the measurement, right? So this is going to be 0.1 m, and volume is known, but we are going to, this is going to be our independent variable, right? Okay, now the volume, now look at the first one. The volume of NaOH needed to reach the equivalence point, so that should be obvious. That should be obvious. Why? Because this is just an what do you call this, equivalence point. Since even though now the volume to attain the equivalence point is 25 milliliter. Why? Because according to this formula, C1 V1 should be equal to C2 V2, right? So the now NaOH, now you know this is, now if you apply CAVA is equal to CBVB, now we have to find out the equivalence point. So at equivalence point we can find out the VB, that is going to be concentration of acid is going to be 0.1 into what is the volume of this acid, that is also again 25 milliliter divided by 0.1. So again that is going to be 25 milliliter. So since we are taking the acid with same concentration, it becomes 25 milliliter. But if the concentration of the acid and bases are different, then it's going to be different, right? So based on the calculation, it may be different. So intuitively, do you understand that? Like
Yeah.
let's say if it is 0.2, then it's going to be different. That's going to be 12.5, right? If the volume of the acid is 0.2, double of the base, it's going to be, the volume will be reduced by 2 factor, twofold, right? Okay. So initially the
Yeah.
solution is 0.1 mole. Okay, so these are just calculation, right? Okay. Now we have to initial concentration we have to calculate. So initial pH value, that's what we have to find out, right? So initially, now initially means when we don't have when we have not added any amount of NaOH. Now let's say we have purely taken this acetate ion. So we will start with 0, right? So in the graph, this is the volume of NaOH. Now at 0 we have not, 0 volume of the NaOH, 0 means what? We have not added NaOH at all, right? So in that case we have to find out the pH. So in that scenario the pH will be solely contributed by the concentration of this acetate ion, right? So to find out the concentration of acetate ion, what should we use? We have to use this ice concept, right? So we have CH3COOH and H2O. So this is going to be, this is the thing, right? So we have already performed a lot of calculations based on this. So I can just simply say that the initial concentration of this CH3COOH 0.1, this is 0, this is also 0, and let's say change is X. That's what we have to find out, right? That's what we have to find out, and that X would be the concentration of H plus ions, right? And the negative log will be the pH, right? Okay. So
Yeah.
here now you can simply plug these values, right? So I'm just going over. If you want, you can, whenever necessary, you take the screenshots, right? So if you want to take any parts of this presentation, you can let me know. I will display them so that you can take the screenshots, right? Because I'm unable
That's
to
okay.
convert.
I normally get the photos quickly anyway.
Okay, that's fine. Because I'm unable to convert it into PDF and share with you. Because I'm writing here and there, I'm not writing in the structured manner. That's why. Okay. Ka, right? So Ka is nothing but you can plug these values here in the equation and X you can find, right? So we have already calculated all these things. I'm just explaining the procedure, right? So if the pH, now we have to find out the pH, and X value should be plugged here, and that is going to be 2.87. 2.87. So here you have to start with 2.87, right? And at 25 degrees Celsius, I'm sorry, that is 25 degrees, not 25 degrees Celsius, 25 milliliter, right? I'm sorry. If you mention the, if you mention the unit of the volume here, you don't want to mention here, you can simply put 25, right? So at 25, we have calculated the required volume of the base, but we haven't calculated the pH. That's what we have to find out now. Okay, right. Now before the equivalence point, right? So now here, okay, now before the equivalence point, we, okay, now tell me, in the, before the equivalence point mean we have undissociated acetic acid and NaOH, right? Do you understand? Right? So before the equivalence point, the added amount of NaOH is stoichiometrically lesser than the amount of acetic acid. Why? Because before the equivalence point, still the solution will have more amount of acetic acid, right? So the pH will be lesser than 7. The pH may be lesser than 7. Okay. Now therefore solution contains undissociated CH3COOH, and okay, now you see we are adding NaOH, and we already have CH3COOH, and we are adding NaOH to this. So when these two substances react, since this acetic acid is an weak what do you call this, weak acid, we will have undissociated CH3COOH, and when NaOH reacts with CH3COOH, it will produce a salt called CH3COONA. So now we already discussed that when CH3COOH, undissociated CH3COOH, and CH3COO minus is present, this is going to be called a buffer solution. Buffer solution, right? And when we have a buffer solution, we can simply use this Henderson-Hasselbalch equation, right? Okay. So now we already studied CH3COOH NaOH. This is going to be the formula, right? And the Henderson-Hasselbalch equation that we are going to use here is this one. pH is equal to pKa plus log pH, right? So here the acid is going to be the CH3COOH, and the acid will have the conjugate base. So we already studied the conjugate acid base pair, right? So what is the conjugate base here?
The conjugate base is CH3COONA.
The CH3COONA. So we have to find out the concentration, right? So we have identified this is going to be a buffer solution, and for the buffer solution we can use this Hasselbalch equation, because we should write the complete name, Henderson-Hasselbalch equation, because for the deriving of this equation two scientists have contributed, that's why, right? So to honor them, that's all. So buffer solution, Henderson-Hasselbalch equation, and for this reaction we have to write down the equation. pH is equal to pKa. Now we have to separately find out, right, pKa. Now you see the components of this equation. We have to find out pH. We should know the pKa, but that can be directly found, right, because since we know the Ka value, and we have to now know the concentration of this base and concentration of this acid. Okay, now, right, so that is our objective, right? So you have to, this is how you have to think, right? They have written everything step by step, but in the examination this is how we have to think, right? So after writing this equation separately, you can find out the concentration of conjugate base, conjugate acid, and then you can plug these values here and find the pH, right? Okay, now, okay, so let's consider the reaction after the addition of 10 milliliter, right? So now you see before, right? So before the equivalence point only it will be a buffer solution. Why? Because then only we will have undissociated CH3COOH. But at the equivalence point, what will have? All the CH3COOH will be completely consumed. So in that case, buffer solution is not possible. Do you understand? If you don't have CH3COOH at the equivalence point, all the CH3COOH will be completely consumed by the NaOH. So will we have? Is it possible to establish buffer solution at equivalence point? Is it possible?
If it's consumed, no, right?
It's not possible. Why? Because we have completely consumed this acetic acid, so it's not possible, right? So before the equivalence point, at any volume we may have buffer solution. So we are just taking, let's consider the reaction after. Now you can take any volume, you can even take 15 milliliter, right? And you can find out the volume, the pH. If you know, this is for your practice, right? So after you have completed this session, you can try for 15 milliliter and check whether you get the pH according to this graph. I will explain how you can draw this graph, and you can check, right? So if it is 15 milliliter, now we are doing, right? So now you can see during this region it will act as a buffer solution. Why? Because before this region we will have both weak acid and its conjugate base. Do you understand? So now you can see the gray color, gray color region can be a buffer region in which we can establish a buffer solution. So we are going to do the calculation for 10 milliliter, but later you can check for 15 milliliter and check if you get this pH. That's for your practice. And you can even do for 20 milliliter, right? Do you understand? Okay.
Yeah.
Now I will just explain this for 10 milliliter. So let's consider we have taken 10 milliliter of NaOH. 10 milliliter of NaOH. So the initial amount of CH3COOH, that's what we have already calculated, 2.5 into 10 power minus 3. Why? Because 0.1 mole decimeter minus 3 is the concentration of this CH3COOH, and this is nothing, right? So initial amount mean 220 C into V, right? So N is equal to C into V. Now this might be kind of complex, the calculation, right? So C is what? 0.1 into that, what's the volume? 25 into 10 power minus 3. So it's going to be 2.5 into 10 power minus 3, right? So that's what we have written here. And this is the concentration. So we wrote 0.1 mole decimeter minus 3. So but they have written in a different way, right? So they have brought the decimeter to the denominator, that's all. And 25 milliliter, and in order to convert this 25 milliliter, they have divided, now they have just written in a different way. I hope you can understand this, right? Do you confuse with this? No, right?
No.
Okay, that's fine. Okay, so added amount of NaOH. Now we are adding only 10 milliliter of NaOH. So added amount of NaOH going to be this, right? So 0.1 into 10 power minus 3. So now, okay, so here what is the remaining CH3COOH? So we already had 25 and this amount is being reacted. So 1.5 into 10 power minus 3 mole will be remaining this amount of CH3COOH. And now we have to find out, now for the pH, the remaining amount of CH3COOH only will contribute, right? So we have to find out the concentration of CH3COOH, and again that is going to be, now you see this amount has been consumed by the NaOH, only this is remaining, right? But the volume is 35. Why? Because we had already 25 milliliter of CH3COOH and additionally we have added 10 milliliter of NaOH. So the net volume of the solution is 35. Okay, so if you multiply this 1.5 into 10 power minus 3 divided by 35 into 10 power minus 3. So they have written in a different way, right? So C is equal to this. This is the C concentration of acetic acid. So if you simplify this and this, 1.5 divided by 35 is going to be 0.43. Now the 0.43 is the concentration of the acid. The concentration of the acid during this buffer region. Why? Because only this amount of acid is present. Other than that, the remaining acetic acid have been converted to salt, right? Do you understand?
Yeah.
Okay. And amount of CH3COO Na formed. Why? Because when you add NaOH, some amount of Na, this salt will be produced, right? So that is going to be simply the amount of NaOH. Why? Because this is going to be a complete reaction, right? That is going to be a complete reaction and it will occur according to stoichiometry. And since we have added 1 into 10 power minus 3 mole of NaOH, that is going to form the same amount of the salt. That is going to form the same amount of salt, right?
Yeah.
Okay. Now that is only the amount. Amount means we have calculated only the moles. But what we need is concentration. What we need is concentration in order to put in this equation. So again, this amount of mole and divided by the entire volume. But the entire volume is now again 35 because we haven't added any extra amount of anything. So 1.0 into 10 power minus 3 is the mole of the salt and it should be divided by the net volume, that is 35. So it is going to be 0.02. So now we have identified this is going to be a buffer solution. So we are going to plug this into this equation. Conjugate base means that is the CH3COOH, right? So let me erase all these things. Right. So here this is going to be pKa plus log concentration of CH3COO minus Na plus divided by CH3COOH concentration. So we have already calculated the concentration of the salt, that is going to be the conjugate base, right? The salt itself is going to be the conjugate base. So that is 0.029 and the acid concentration, the remaining acid concentration after reacting with NaOH, that is going to be 0.043. So if you, and pKa means minus log Ka, right? So minus log Ka means you can calculate, right? So we have already calculated them as well, 4.74, and pH going to be 4.57. So when 4.57 when you added 10 milliliter. So again you can draw a graph, right? So this is going to be 25 milliliter, this is going to be 10 milliliter. So starting from that value 10 milliliter, you can plot this, and again before 25 you have to calculate, and after 25. This is what we are going to actually do to draw a nice graph. Okay, now let's move to the next step, right? At the equivalence point, we haven't calculated the pH, right? Do you understand that?
Yeah.
Okay, so now at the equivalence point, after adding all 25 milliliter of NaOH, what will happen? All the CH3COOH minus will be consumed, right? So we will not have any CH3COOH. Only we will have is the salt. Only we will have the salt. Do you understand that?
Yeah.
Only the salt. So the salt CH3NO present. Okay, so under hydrolysis. Now CH3COONA only will be present, but that can undergo hydrolysis. Why? Because in the solution anyways we will have water. So the equilibrium reaction that will be established during the equivalence point will be this. The only thing that we will have in the solution at equivalence point is the salt and water. Why? Water is coming from, because we have already, because since this is aqueous, definitely we will have water, and the only thing we have at equivalence point is salt, neither acid nor the base. Okay, so according to the reaction we have to again use this, right? So we have calculated the initial concentration of this CH3COOH. Okay, right. So before that we have to find out the salt concentration, right? So the salt concentration, how can you calculate the salt concentration? That is going to be 2.5 into 10 power minus 3. This amount of salt has been formed. That is what we already wrote here. Yeah. We already discussed. Since the reaction happens according to stoichiometry, and since we have used this 2.5 into 10, okay, so what will happen? Now we have 2.5 into 10 power minus 3 mole of NaOH. So everything should have been consumed. So how much of this salt will be produced? That is obvious. Do you understand? I wrote somewhere. Okay, that is obvious, right? So definitely the equal amount of the amount equal to the what do you call this, NaOH will be formed as salt, right? So that is going to be 25 point minus 3. So this is nothing but the amount of NaOH, right? The amount of NaOH. So the same amount of salt will be produced. But what is the net volume? We already had 25 milliliter of acetic acid, and at equivalence point we should have added 25 milliliter. 25 plus 25 is going to be 50 milliliter. So we are going to divide it by 50 milliliter, and it's going to be 0.05 mole decimeter minus 3. So now you can observe what do you call this, equilibrium reaction. So the initial concentration means again it is going to be encounter hydrolysis, but the initial amount of produced, now we have not directly added, it has been formed, but for this scenario it is going to be considered as the initial concentration of this acetic acid. I'm sorry, as the conjugate base, right? Conjugate base, that is going to be the weak acid salt. Okay, right? So the change, that's what we have to find out. As OH minus concentration, and from that we can find out the pH, right? So the equilibrium constant and everything, so we have already done, right? So 0.05 minus x. So we have just ignored this x, because when we compare, this x is going to be very, very less, right? When we compare the concentration of this acid, that is going to be 0.05, but this x may be 0.00000. So it is negligible. So that's why we have ignored that value, and this is considered as 0.05 and xx. So at equilibrium we have to plug these values, and we are dealing with Kb, right? Why? This is actually accepting OH minus.
uh,
This is accepting H plus. I'm sorry. So is
yeah.
this acid or base? Here is it
Base.
base?
If
Why?
it's accepting.
Because it is accepting H plus to form this CH3COOH. So we have to write down Kb value, right? So the Kb value of this acid, you can get it from the data sheet. It's going to be 5.6 into 10 power minus 10. Okay, Kb value.
Okay.
And x squared, and here CH3COO minus 0.05. This is x squared, and you know how to write the Kb value for this equation. This is what we already studied, right? So POH. Now Kb becomes this, right? Kb becomes this.
5.6 times 10 minus 10, yeah.
Okay, 5.6 into 10 power minus 10. So here x is going to be you can, if you simplify,
10 minus.
yeah, if you simplify, can you simplify and try check if you get this value? So square root of 0.05 into 5.6 into 10 power minus 10, right? So x is going to be this. So do you check, can you check and get this value?
Yeah.
Okay, now so this is going to be x, right? So we can find out POH. How? So minus log this value, and that, okay, now you can check later, right? So, or should I do this instantly? So you can check later, right? So you can check later because we have done enough questions here. So here you can write pH is okay, no, POH is going to be minus log this value 5.3 into 10 power minus 6. So that is going to be 5.28. So pH is going to be 8.72 because of 14 minus this value, right? So now at equivalence point we have calculated the pH as this, right? So now 0 we calculated, and at 10 milliliter we have calculated the pH, and at equivalence point also we have calculated the pH. Okay, now after that we are going to take another scenario, right? So after the equivalence point, the total amount of converted to, okay, right now okay, now after 25 milliliter is the equivalence point. So we took 10 milliliter before 10 milliliter, right? The difference is 15. Again 35 milliliter. If you add 35 milliliter of NaOH, so at every volume you can perform the calculation. At every volume you can perform the calculation, but the same step, only the difference will be, only the values will be different, right? So again you have to apply the same thing, right? Initial amount of CH3COOH, this one we already calculated, and we have added this amount of, why? Because 0.1 into 2.5 in 0.1. okay, so what is the amount of NaOH added? So that is going to be 0.1 C into V, right? 0.1 into 35. Why? Because we are adding 35. In the statement they are mentioning 35 NaOH, or experimentally we are adding 35 milliliter of NaOH, right? So 35 into 10 power minus 3, it's going to be 3.5 into 10 power minus 3. Okay, so here the reacted one will be 2.5. Why? Because only this amount of CH3COOH will react, right? Because only that amount of CH3COOH we have in the solution, and what will be remaining here? So here the what do you call this, limiting reagent would be acetic acid. So the remaining will be NaOH. Why? Because after the equivalence point we will have NaOH in excess. Why? Do you understand that? So we have added more amount of NaOH, and all the acetic acid have been consumed, and the remaining will be NaOH. So how can you find out the NaOH? So 35 into this amount we originally had, and this amount had reacted, so 1 into 10 power minus 3, and so this is the concentration of NaOH. So divided by 60. Why? Because 25 plus 35 is going to be 60. So 0.17 is going to be the, this is going to be the what? The concentration of OH minus. So you can calculate POH, and from that you can calculate pH also. So you can see that the pH is increasing when you add OH minus, but there will be some steepness, right? So at every temperature there will be steepness, right? So these are the alternative ways. We don't want to actually bother about that. Now you can see here this one, right? At 25 degrees Celsius it was, what's the value? We already 12.23, right? At 25 degrees Celsius the pH was, what's the value? 8.72, right? 8.72. At 25 degrees Celsius 8.72, somewhere here, and at 10 milliliter here, right, this value, and at 35 milliliter this value. So if you take, okay, now you can take, right, so 24.9 milliliter of NaOH. Now you can 24.9 milliliter of NaOH is added. This is going to be a buffer solution. Why? Because we have NaOH, I'm sorry, we have acetic acid and its base, and the what do you call this, salt also will be there. So again you have to apply the Henderson-Hasselbalch equation here also. So you can find out the pH using the same well.